So last session, what did we learn about? Can someone help me recall? What concepts did we discuss? We learned about the formula, right? How traffic intensity is calculated, and based on how many calls, and what is going to be the duration of the call, and how the service of the network is actually uh, calculated. Okay, so many times what is going to happen whenever there's a I don't know if you all know, there were many networks before. Okay, and as the competition started heating up, right? So most of those operators who were not performing well had to back off, or probably they had to merge with some major service provider, right? So this happens when the competition, increases, and these small operators, right, are not able to compete. Why does this happen? Because I think you all are very much aware of the concept of MNP, right? Are you all aware of this MNP? I think by now all of you should be knowing that concept, right? Which government recently brought in a few years back. What is MNP? It's a general question. Come on.
Mobile number portability.
Good. So what is the advantage of this? Was it for the good or for the bad, or why was it actually brought up?
So you can change from one network provider to another without changing the number.
Okay, is that the only advantage, or we're looking at something else bigger? Is there a bigger picture behind it?
Sir, also the phone number stays the same. Like you don't need to change it while
Good.
changing it from one provider to another.
Good. That is one point. And then the real thing, that's happening in mobile number portability is, customers were given a choice to move on from one network to another network. So very important thing here, what is happening is, they were able to select operators. And how do we select? Do we select the worst? I don't think so, right? We always need the best. So that network which provides proper, facilities, proper services, proper tariffs. So people obviously will try to move on to it. So in this way, what happened is once MNP came up, the small operators couldn't, stand up the competition. So they had to back off. In one way, it's a good thing to bring in positive competition, right? Wherein the quality increases, and at the end, weak customers are benefited, right? So why am I telling you all this is because of the traffic intensity that we were discussing about, right? So if the traffic carrying capability of a network increases, right? So there can be less number of disconnects. There can be less number of voice responses saying that all lines are busy, all routes are busy. I think you would have heard this, right? Once or twice. So that happens when all the lines are connected and all the channels are occupied, and there's no way of disconnecting a channel because it's just been allocated to a subscriber, and it cannot be disconnected abruptly. Once probably that time limit is over, then only you can disconnect. So there are a lot of parameters, right? So one such parameter was calculating the network's performance, and one way of calculating its performance was having the intensity formula, trying to find out how many calls are there, how many is it able to process, and what is going to be the holding time, how much time it's going to take to connect to a call, and while traveling, right? Especially how well you're connected to the network, right? So all these things matter. So MNP opened a door of opportunities for customers as well as for operators. So indirectly, it was a threat to the operators, and it was on the advantage side for the customers, right? So because, how do I say that it was a threat, is because they had to increase their services, or probably they had to increase their level of quality. So those operators which were able to sustain, right, were uh, maintaining those standards. And of course, there's no point in having 10-15 operators, right, service providers. So around 3 to 4 is good. So right now, we are left out with these 3 to 4 operators only, right? So this was about the MNP concept, and calculating or trying to find out how this network is functional all about. Okay, now there are few more parameters that we can look into. Okay, I think we looked into this ISDN, right, integrated services digital network, where it not only provides the network for voice calling, but then also for data, right? So that became an integral part. Just imagine, these days without the internet connection, life becomes so difficult. And we are so much dependent on the internet, just like how we are right now with electricity, right? So before this electricity came into picture, right, people were somehow trying to manage and going around with their day-to-day lives. But then once this electricity came into picture, there became a whole lot of families that are getting attached to electricity. For example, it can be batteries, the battery family getting attached to electricity because it needs to store the charges, and then probably the drive machines, right, the electric machines, and it can be the motors. So all these systems were developed keeping electricity in mind. So right now, networks are built keeping internet, keeping reliability, keeping performance, okay, keeping delay, all this in mind. Okay, now the reason why we are trying to move on from one technology to another is only because that we need to have an advantage, right? Usually when we move on from one generation to another, remember I was talking to you about the first generation and the second generation, then 2.5, then 3, 3.5, 4. Right now, a lot of things happening in 5G. So the reason why we move on from one tech to another tech is because we see a wider uh, picture, right? We see a whole lot of advantages, right, compared to less number of disadvantages. So if the advantages are overtaking the disadvantages, then obviously we will try to take it, right? So one such thing is going to be the speed, okay, the way in which the service provider provides the internet speeds. So ISDN started off with that, right, giving an integrated service. And yeah, so not only that, these days we have technologies called VoLT, right? So that is nothing but voice over. It is also called VoIP, right? VoIP, voice over internet protocol. So here, they probably term it as VoLT because the voice over long-term evolution networks, right? I will give you a small homework, okay? Probably right after this class, you guys try to differentiate between 4G, okay, advanced 4G and LTE, right? Try to come up with differences between these three, right? And we will maybe discuss about it in the next class. Will that be fine, all of you? Yes. Can you do a small research on that? And maybe we can have a discussion on it. Yes.
Yes, sir.
Yes, sir.
Fine, fine. That is good. Okay. See, because we are using the network, we need to know what is about the network, isn't it? Day-to-day life we are using, and if we do not know what it is all about, that's where we are stopping our learning, right? So So let us look into it. What is exactly into the technology, what kind of circuitries are used, and what is making it faster. So all these things, right? And maybe we can think of some kind of presentation, wherein all of us can be benefited. Okay, so the call connections were faster, and it was more reliable. Why was it reliable? Because I'm sure that if I want to connect to the internet, it will connect. It's not that it may connect, it may not connect. Some days it works, some days it may not work, right? So that's not called a reliable network. So a reliable network is something where any time, any point, it should just connect and keep giving you services, right? Okay, then we also looked into ADSL, right? Asymmetric digital subscriber line, where there was a huge difference between the uploads and download speeds, right? So usually our requests, as as a normal customer, we would have more number of downloads than uploads, right? Only content creators probably will have a lot of uploads, right? And probably developers. Apart from that, common people will probably use the downloads more than the upload. So accordingly, we had asymmetric networks, right? Asymmetric DSL lines where download speeds were made more, so that it can benefit majority of the people, right? And there were few connections specifically made to have both download and uploads to be the same speed, right? Okay. Then we also saw ADSL works by allocating a majority of available phone frequencies for communication of downstream traffic. Downstream is nothing but when you send packets from the server, right? When you are sending information to the server, that becomes your upload or upstream traffic. ADSL possesses all of these characteristics one associates with DSL, including high speed service, always on. So it's not like you need to do a procedure in order to connect to the internet. You need to write a code, to and execute to connect to the internet. You need to go through a GUI and connect to the internet. No, nothing as such, right? You're always connected, right? You can just on and off. That's it. So, the service providers, the manufacturers try to make things more simpler and more intuitive, so that, people become more engaged, right? They become more engaged and they try to, involve themselves in, using the services. If in case, you find that, using the technology is so difficult, right? We wouldn't opt for it. That's the bottom line, isn't it? So we want things to be simple, right? We want things to be fast, and we want things to be reliable, and most importantly, we want it in a proper price range, right? Okay, fine. For ADSL to work, only a microfilter and a ADSL modem needs to be installed. So you just had to have a filter designed, which the company would probably provide it free of cost, and the modem also would be given free of cost. So these days, these offers and this tariffs are made so attractive that customer would want to have a connection, right? Uh, and these days, as I mentioned, it's become a necessity. Okay, now let us look into a small problem here, and with this, we'll be able to understand what is going to be the parameters that are actually looked into when we decide what kind of networks, and what things are actually evaluated while talking about the performance of a network during the busy hour. Okay, usually we have two types, right? The peak hours and non-peak hours. I don't know if you all can recall, right? Most of the service providers, provide benefits, right? Minutes, talk minutes, or probably talk time, or they would reduce your call charges by half when you call during off-peak times, right? So that used to be previously, where people used to wait for this off-peak times, probably after 10 p.m. and up till 6 a.m. or probably 7 a.m. And initially what these service providers were doing was, they were trying to give probably by 9, okay, 9 to say 7, and then they found out that 9 to 10 people are all awake and they are making the best use of the network. So what they did was, instead of 9, they started telling that from 10 we will give this service. So 10, and then people started being awake after 10, 10 to probably 11:30, and that was the peak, and they were finding the network to be having a lot of glitches, because everyone are trying to call. And the best part is, those calls used to be free, or probably it used to be charged at 5 paise per minute. So these were the kind of offers given. Why were these offers given? So that during the daytime, when the normal communication happens, right, there shouldn't be any glitches. So there's a bigger picture here, right? These service providers, they had to, instead of investing in building up their networks, right, they can just give this offers, and people, instead of calling during the daytime, they can probably utilize these offers. So it's a win-win situation for both, right? It's for the customers benefit also, and even for the service providers. Of course, they have invested a lot, and they have done a lot of R&D, right, based on what is going to be the number of users, and if the number of users increases, then how are we holding up the network. So there always will be a lot of research happening whenever a network is set up, right? They just don't set it up. In fact, there will be a lot of trial phases, right? So even the operator will have a lot of expenses, right? And not only that, they need to provide a competitive price in the market. So it's like a very complex web that we are looking into, right? Even they need to make profits. Even they should provide good offers, and even the customer should be happy, and more people should join the network. So there are a lot of parameters that we are looking into, right? So it's a big game altogether, right? So it's called optimization, right? Something which comes with you want to give something best, but then you're not able to, so you kind of settle into a level where that becomes more appropriate to both the sides. When I say both the sides, well, with the network providers and with the customer, right? So that was about the busy hour. So during the busy hour, that is the peak time, 1,200 calls were offered. This is just taken as an example, right? Were offered to a group of trunks, and 6 calls were lost. So during this, see, sometimes your call gets through and sometimes it doesn't get through, right? So this is called calls getting lost, where you're trying to dial, but then it's not able to connect, maybe because the network is congested, there are no channels available, right? Or probably there was a glitch in the network, some reason, right? So 6 calls were lost. The average call duration
Sir,
was
is call lost similar to call drop?
we can say call drop, that comes in grade of service, right? And calls lost, not getting connected, yeah, we can put them all together. Okay, you're trying to establish a call, and it's not getting established, so you've lost the call. And maybe when you're traveling, you're in a call and then the call gets disconnected, yeah. So these are called losing calls. Fine. Okay. So the average call duration was about 3 minutes. Okay, so they try to average and find out, what is the usage of the channel, right? So it was approximately about 3 minutes, and now we need to calculate about 5 parameters. What was the traffic offered? How much of traffic was carried? What was the traffic lost? And what is the grade of service, the quality of service, right? And the total duration that the network was in congestion. So all these 5 are very important, right? Why do I say these are important? Is because these can actually handle all the parameters, so to say, right? So depending on how the network is performing, and what best that they can offer to their customers, right? So there are certain formulas associated, right? Traffic offered. So that is nothing but we call it as C into T by T. So I am taking here C1. Okay. So this is nothing but 1200. It is just brought here the number of calls, and it's all in minutes, right? So 3 minutes. Okay. And into 3, okay, C into T, and 60 seconds, right? So T is always taken in seconds. So 1200 into 3 divided by 60. So that should give me 60 E. Can someone tell me what is this E? That's a unit, right? So what is that E?
Sir, Erlang.
Very good, right? So that is the unit of traffic. Okay, so now we have the traffic offered. I will just put it as A, so that I'll be using this A and B later, right? So this is going to be the only formula, right? So I know that now my traffic offered is about 60 furlongs. Now I need to calculate the traffic carried, right? Traffic carried. 1200 were offered, but then how many got lost? 6 got lost. So which means 6 were not carried at all. Okay, it was either left halfway through, or probably it didn't uh, end well, right? So that is what we are trying to say here. If you can recall, right, we had something called the service charges, where an operator A calls to an operator B, and operator B had to pay the service charges to operator A, right, wherever the call terminates. So here in this case, 6 calls were not terminated properly. Either it can be the call is not getting established, or probably getting missed out halfway, right? So there was abrupt call disconnects. Mostly, we can probably refer this to calls never been established instead of calls being abruptly disconnected, right? So even calls being abruptly disconnected can also be termed as call disconnects, but then it's not a call loss, right? So this mostly refers to the call which was never been able to establish, or just established and then disconnected, right, without any communication happening, right? So 6 calls were of that sort, and we try to minus them. So the same 3 minutes 60. So we are having a traffic carried was about 59.7. So offered was 60, but then carried was only 59.7. Okay, so next I have to calculate how much was lost. So we know 6 calls were lost, right? So 6 into 3 by 60, right? So about 0.3 was the loss. So even if you minus these two, right, offered and carried, you will be getting this value. Okay, so I take this as A, I take this as B. So offered is A, lost is B, and I calculate the grade of service, right? How many calls were actually supposed to carry, or how many calls were actually came in, and what was the loss, right? So loss will be in the numerator, and at the denominator will be the total number of calls offered. So 0.3, okay, divided by 60. A is nothing but 60 furlongs. So the grade of service is going to be 0.005. Okay, now this doesn't have an unit because at the numerator and denominator we have both furlongs. Right. Okay, and so that's the traffic lost. Then the grade of service. Okay, what grade is my service that is offered, right? So B by A. Okay, so we looked into it that we're getting about 0.005. Now the total duration of the periods of congestion. So congestion was there, and hence it didn't happen, right? And hence it didn't go through. So grade of service, right, that is B, okay, into T. Okay, so actually this should be grade of service is equal to B into T. So B is equal to 0.3. It is not 0.3, it should be actually grade of service here, right? So grade of service which is 0.005 into 3600. So what is this 3600? 60 into 60. Okay, so we calculated for an hour, right? So 60 minutes and 60 seconds. So in an hour, what is going to be? So an hour is taken as base, right? So we multiply the grade into the duration. So for per hour, about 18 seconds was the congestion period, and rest of the time it was fine. So for 18 seconds, my network was congested. So this kind of calculations, will actually help us understand how to increase the performance of the network. How can I make this 18 seconds into probably say 1 second or 2 seconds, right? Or probably even zero. Practically speaking, zero is a little difficult, but then it is possible, right? It is possible. But then it's going to be on the higher side, right? The tariffs are going to be a little higher. So again, optimization comes into picture, right? I was talking to you about optimization, where things are brought into a level where you are not degraded by the service, nor you have the best standards available. But right now, if you think, our networks have really matured a lot, compared to those previously, right? When 3G came in, of course 3G was brought into world in 2000, and then for us, it actually caught up. We started getting it in the late, probably somewhere 2007, 2010, something like that. But then when 4G came up, believe it or not, 4G was actually brought in 2010. And when 4G came up, right, the gap, that it came into our country, was actually reduced drastically. Probably in 2 3 years, we were able to establish, right? So this gap, which means the technology being adopted, right, or being adopted or getting adopted, is actually getting faster. So rate of adoption is being fast. Right. So, this is how, traffic is calculated and networks are monitored, and, things are done, in this fashion. So students, any doubts that you have with respect to what we have discussed so far today? Any queries or anything that you want me to come up in the next session? Okay, fine. So we'll be looking at probably few more concepts in our next class, and we will see how best that we can actually. I have lined up few things. Let me just show you as to what we're going to look into probably in the next class. Right, we will be. I'll just tell you, right, as to what we are going to look into. We'll be looking into DC supplies, right? We'll be looking into UPS, and we'll also be looking into the optical fibers, right? Mm, and then we'll be studying about the optical fiber, cross-sectional areas and refraction, okay, all those things. We'll be also looking into FSK, PSK, ASK, and Hartley-Shannon's law. So few concepts here and there, right? And the guard time, sampling time, right? So all this will be looking into. So it's actually going to be interesting, right? Where we try learning more and more about these things and trying to understand the performance and parameters involved in the networks, right? So can we end our session, students? Yeah, if there's no doubts. Yes, no. Okay, fine.
Yes, sir.
Yeah, thank you.